Something hit Earth over the Arctic Ocean in February 2025, and the government satellites that track ballistic missile launches picked it up. It was moving at 59 kilometers per second. The escape velocity from our solar system is 42 kilometers per second. Whatever hit the atmosphere over the Barents Sea was not from our solar system. It came from somewhere else entirely, and it is not the only one. Researchers running calculations published in early 2026 concluded that right now, at this exact moment, there are approximately 35 million interstellar objects inside the orbit of Earth around the Sun. Not out past Neptune, not in the distant Kuiper Belt, but inside the orbit where Earth lives. 35 million pieces of other star systems silently sharing our cosmic neighborhood. And we had no idea until about 5 minutes ago in astronomical terms. And that is just the beginning of what we now know. Because 3I Atlas, the giant interstellar comet that tore through our solar system in 2025 and left scientists openly baffled, has been handing us data ever since. And some of what that data is showing, published in peer-reviewed journals just weeks ago, is the strangest thing astronomers have ever read off any object in the history of modern space science. Let's build this properly. Because to understand why everything happening right now is so significant, you need to understand how fast the picture changed. For all of recorded human history, we had never seen a single object from another star system pass through our solar system. Not one. Space is big, objects are small, and our telescopes for most of history were simply not sensitive enough to catch something moving that fast at that distance. Then, in 2017, ʻOumuamua showed up. Strange shape, no tail, and an acceleration that nobody could fully explain. Scientists spent years arguing about what it was. Then in 2019, Borisov came through. It looked more like a normal comet, behaved more predictably, gave scientists a breath of relief. 2 objects in 2 years after zero in all of human history. That alone should have told us something important about how common these visitors actually are. Then in July 2025, everything changed again. In early July of 2025, a third interstellar interloper was discovered. Originally known as A1PL3Z, then rechristened as 3I Atlas after being confirmed to be of interstellar origin. The Atlas Survey Telescope in Chile, the same network that watches the sky for asteroid impacts on Earth, caught a faint moving point of light on July 1st, 2025. Within days, the orbit was computed, and the orbit said the same thing ʻOumuamua's orbit had said 8 years earlier. This thing is not from here. But 3I Atlas was different from the first 2 in ways that immediately started making astronomers uncomfortable. All of our preparation for the next interstellar object was preparing for something that looked like ʻOumuamua, or something that looked like Borisov. And this thing does not look like either of them, which is crazy and exciting. Those exact words from a professional astronomer. Crazy and exciting. Not a quote from a YouTube channel, but from the scientific literature. The first difference was speed. 3I Atlas was traveling at an unexpectedly high velocity, about 130,000 miles per hour. This is much faster than the 2 previously detected interstellar objects. Fast enough that it had been traveling through the galaxy for an almost incomprehensible amount of time. The most recent interstellar visitor was crisscrossing our galaxy for some 10 to 12 billion years before it came near the Sun. 10 to 12 billion years old. Earth is 5 billion years old. This object started its journey before the planet you're standing on existed. It was already ancient when the first single-celled life was figuring out how to divide on the surface of a young Earth. The second difference was size. ʻOumuamua was roughly the size of a football field. 3I Atlas is a different scale of problem entirely. From Hubble Space Telescope observations, the diameter of its nucleus was not less than 1/400 feet, and not greater than 5 miles across. And that size created an immediate statistical crisis that Harvard astrophysicist Avi Loeb raised in a paper almost immediately. We should have detected an order of 100,000 ʻOumuamuas before discovering an object as big as 3I Atlas. This introduces a puzzle in terms of our expectations about interstellar object populations. The models say you should see a huge number of small ones before you see a giant one, because small objects are far more common than large objects in any population. We saw one small one in 2017, and then jumped straight to something potentially 1,000,000 times more massive. That does not fit any known distribution. Something in our models is wrong. And then the science teams pointed every major telescope on Earth and in space directly at 3I Atlas. The James Webb Space Telescope, Hubble, the Subaru Telescope in Hawaii, the ALMA Array in Chile, NASA's Europa Clipper spacecraft captured observations when Earth-based telescopes were temporarily blinded. 12 separate NASA assets alone captured and processed imagery of this object. What they found over the following months has produced paper after paper, each one adding another layer of strange to an already extraordinary object. The water is wrong. This is the finding that caused the loudest reaction in the scientific community. Every comet that has ever been studied in our solar system contains water, and that water has a certain ratio of regular hydrogen to deuterium, the heavier version of hydrogen that has an extra neutron. This ratio is like a chemical fingerprint. It tells you something about where and how cold an object formed. In all the comets we have ever studied across our entire solar system, the deuterium to hydrogen ratio stays within a certain range. The findings from a study led by the University of Michigan revealed extraordinarily high levels of deuterium. The amount of deuterium with respect to ordinary hydrogen and water is higher than anything we have seen before in other planetary systems and planetary comets. Higher than anything ever seen, not a little higher. The measurements published in Nature Astronomy showed a deuterium to hydrogen ratio more than 10 times higher than any solar system comet ever measured. They found 1 deuterium and 100 hydrogen atoms in water around 3I Atlas. The 12C to 13C ratios also exceeded typical values found in the solar system and nearby interstellar clouds and protoplanetary disks. Both the water chemistry and the carbon isotope ratios are off the charts compared to anything we have ever seen in our own neighborhood. Our new observations show that the conditions that led to the formation of our solar system are much different from how planetary systems evolved in different parts of our galaxy. The conditions that formed our solar system are different from wherever 3I Atlas came from. We are not looking at a universal template for how planetary systems form. We are looking at genuine alien chemistry from a place that formed under completely different physical conditions than anything we have direct access to. But the water was just the beginning. Then the methane results came in. NASA's James Webb Space Telescope uncovered unusual chemistry in interstellar comet 3I Atlas, including the first direct detection of methane on a visitor from another star system. And the methane was not just there. It was there in quantities that made scientists stop and check their instruments. They discovered a staggering methane to water ratio, roughly 11 times higher than any previously measured solar system object, 11 times higher than any comet we have ever studied in our own solar system. And the deuterium enrichment in the methane was even more extreme than in the water. They found 1 deuterium in 30 hydrogen atoms in the organic molecule of methane around 3I Atlas. The James Webb Space Telescope, the most sensitive instrument humanity has ever pointed at the sky, was reading chemistry off a passing interstellar object that simply does not exist in any solar system body we have ever catalogued. 3I Atlas is not a weird comet. It is a comet from a completely different kind of star system that formed under conditions that do not exist anywhere near us. And then there was the SETI search. Because when you have an object this unusual passing through your solar system, you point the most powerful radio telescope on Earth directly at it, and you listen. A narrowband radio technosignature search toward 3I Atlas was conducted using the 500-meter aperture spherical telescope, the largest radio telescope in the world, from October 2025 to January 2026 on 4 separate dates. No credible narrowband radio technosignatures were detected from 3I Atlas after visual inspections. No signal, no transmission, nothing that looks like technology broadcasting on radio frequencies. The SETI Institute also ran its own search using the Allen Telescope Array. Same result, silence. So we listened properly with the biggest ears we have, and 3I Atlas said nothing back. But silence is not the same as natural. The absence of a radio signal means it is not broadcasting to us on radio frequencies. It does not tell us what it is. And Avi Loeb's position, but stated publicly and repeatedly throughout 2025 and 2026, is that the anomalies in 3I Atlas are real and need to be taken seriously rather than explained away. Loeb pointed to its path in the ecliptic plane of the planets around the Sun, which is aligned by only 5 degrees. The chance of this happening at random is 1 in 500. Its size is very anomalous, approximately 1 million times more massive than ʻOumuamua. Its composition contains nickel and very little iron, the way we find in industry-rich alloys with aerospace application. 1 in 500 chance of the orbital alignment happening by random. 1 million times more massive than ʻOumuamua. Nickel-dominant composition. Methane levels 11 times higher than any known solar system comet. Deuterium 30 times more enriched in water than typical bodies. These are not normal numbers for a normal comet. Each individual anomaly might have an explanation. But the cluster of them together on the same object moving through our solar system right now is what serious scientists are struggling to fully account for. Now, here is where the story takes a turn that most people have completely missed. Because while everyone was focused on 3I Atlas as it passed through our inner solar system and rounded the Sun in late October 2025 and headed back out toward Jupiter and beyond, something else was being quietly calculated in the background. And the calculation published in February 2026 by Avi Loeb and his postdoctoral researcher Richard Cloete arrived at a number so large that most people who heard it assumed it had to be wrong. Harvard scientist Avi Loeb has claimed that there could be 35 million interstellar objects inside Earth's orbit. He studied two meteors that probably came from another star system to estimate the number of interstellar objects in our solar system. The methodology was elegant and disturbing. The U.S. government maintains a database called CNEOS, the Center for Near-Earth Object Studies Fireball Catalog. This database is populated by the same military satellites that watch for ballistic missile launches and nuclear tests. Every time something burns up in the atmosphere bright enough to register, the satellites catch it, record its velocity, and the data eventually gets declassified and posted publicly. When a 3-meter object collides with Earth, its friction on air generates a meteor fireball with an energy output comparable to the Hiroshima atomic bomb. Such an explosion is easily detectable by the U.S. government satellites, which are monitoring Earth routinely for the heat emitted by the launch of ballistic missiles. Loeb and Cloete went through that database and looked for objects moving faster than the solar system's escape velocity, faster than 42. 1 kilometers per second. An object moving that fast cannot be gravitationally bound to the sun. It has to come from outside. They found two. CNEOS 22 was detected on July the 28th, 2022 over the eastern tropical Pacific Ocean, exceeding escape velocity by 7 standard deviations. CNEOS 25 was detected on February 12th, 2025 over the Barents Sea in the Arctic, exceeding escape velocity by 5 standard deviations. And then there's the one discovered in April 2026. A meteor from April 1st, 2026, with a polar velocity component of 59, 8 kilometers per second, well above the local escape speed from the solar system of 42, 14 kilometers per second. The interstellar origin was confirmed with a statistical confidence of over 997%. The reported coordinates place the event over the South Atlantic Ocean east of Argentina. Pieces of other star systems are hitting Earth's atmosphere. Not in the past, not theoretically. In 2022, 2025, and in April 2026, we have the data from government satellites. The velocities have been confirmed. The interstellar origin has been established at statistical confidence levels that would be considered bulletproof in any scientific context. And from those two confirmed interstellar meteors in 7 years of the catalog, Loeb calculated a collision rate of about 0.3 per year. Then he worked backwards through the geometry of Earth's cross-sectional area and orbital speed to figure out how many objects must exist in the surrounding volume of space to produce that collision rate. This implies that there are about 35 million meter-scale interstellar objects embedded at any time within the orbit of the Earth around the Sun. Assuming they have a solid density of a few grams per cubic centimeter, each object carries about 3 million metric tons. Altogether, the population totals about 100 trillion metric tons interior to the Earth's orbit. 100 trillion metric tons of interstellar material right now inside Earth's orbital path. Pieces of other star systems traveling through our solar neighborhood, some of them hitting our atmosphere and burning up as fireballs that military satellites register, and government researchers catalog, and mostly nobody notices. The solar system is not an island. It is not a quiet, isolated bubble floating through empty space. It is permeable, constantly being threaded through by visitors from other stellar systems, some the size of mountains, some the size of a car. And we are only just now developing the instruments to see them. And here is what makes everything that is happening in 2026 the actual breaking news that you should care about. Because a new telescope just came online and it is about to change the frequency of these discoveries from once-a-decade events to something that looks more like routine monitoring. The Vera Rubin Observatory issued 800,000 alerts to astronomers on a single night on February 24th, 2026. The NSF DOE Vera Rubin Observatory is expected to produce up to 7 million alerts of asteroids, glowing black holes, and cosmic explosions every night. 7 million alerts per night from a single telescope in Chile, the world's largest digital camera, 2 gigapixels, photographing the entire southern hemisphere sky every few nights, producing a time-lapse of the changing universe at a resolution and sensitivity that has never existed before. And one of the specific things it is designed to catch, that it has already proven it can catch, is fast-moving interstellar objects passing through our solar system. There should be around 10,000 interstellar objects within the orbit of Neptune at any given time. The best estimates suggest Rubin should detect between 5 and 50 interstellar objects over its 10-year survey. If interstellar objects are more common than the first 3 discoveries imply, that rate could be higher, 5 to 50 over 10 years. At the upper end, that is 1 new confirmed interstellar visitor every few months. Not every decade, every few months. It could be 5 to 500, depending on how often these objects are ejected from their home systems, 5 to 500. The uncertainty in that range tells you exactly how little we actually know about what is out there. And Rubin is about to start collapsing that uncertainty 1 detection at a time. Avi Loeb is already thinking ahead to the next confirmed object. He has given it a name in anticipation. For I, Rubin. the NSF-DOE. Rubin Observatory in Chile is expected to discover dozens of new interstellar objects within the next decade. These visitors to our cosmic backyard will be flagged by their speed exceeding the value needed to escape from the pull of the sun's gravity. With a forward-looking mindset, let us hitchhike the next interstellar visitor for Rubin. Hitchhike. His proposal is that when the next interstellar object is detected, we should be ready to attach a small spacecraft to it and let it carry our technology back out into the galaxy. A close-up photograph just before impact would unravel the nature of future interstellar objects. In addition to a camera, the interceptor could carry instruments that would probe the composition of the plume of gas or dust around the interstellar object. Even if the object turns out to be a natural iceberg, the instruments on board could check whether the iceberg carries any biological signatures, or the building blocks of life in the form of organic molecules. Biological signatures, the building blocks of life. We found methane 11 times more enriched than anything in our solar system on 3I Atlas. We found deuterium ratios that imply formation in conditions so cold and so alien that they simply do not exist anywhere near us. The next time one of these objects comes through, we have a chance to get up close and actually find out what it is carrying, not from a telescope, but from an instrument riding alongside it, sampling its material as it moves. And there is one more number that needs to sit in your mind before this is over. Interstellar objects like 3I Atlas travel a few times faster than all 5 human-made probes launched to interstellar space so far. Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, New Horizons. All 5 of our spacecraft that have left or are leaving the solar system, every single one of them moves slower than the average interstellar comet passing through our neighborhood. Our fastest probes, the product of decades of engineering at the limits of what human civilization can currently achieve, are slower than the rocks that fall through here from other star systems. That single fact contains everything you need to know about where we are in the cosmic picture. We are a civilization that has just barely managed to throw a few small probes past the edge of our own star system. Objects from other star systems pass through our solar system regularly, some of them hitting our atmosphere and burning up as fireballs that military satellites log and scientists eventually count. And now, for the first time in the history of our species, we have an instrument powerful enough to actually catch them as they arrive in real time before they have already passed us by. 3I Atlas came and went. It is now past Jupiter and heading for the outer solar system, carrying its ancient alien chemistry and its impossible water ratios and its methane levels that no solar system object has ever matched back out into the interstellar dark from which it came after 12 billion years of travel. We had months to study it. We had every major telescope in the world pointed at it. And what we learned is that whatever conditions formed it are completely different from the conditions that formed our solar system. That other planetary systems produce chemistry we have never seen. That the universe is far stranger and more varied in its building blocks than our local sample of one solar system ever suggested. The next one is coming. Rubin is watching. The Kineos satellites are watching. The SETI telescopes are listening. And for the first time, we are actually ready. Not to catch a passing mystery and watch it disappear, but to intercept it, to sample it, to ride alongside it for a few precious months before it escapes us forever at 130,000 miles per hour back to wherever it came from. The solar system is not alone. It never was.